Good morning, students. I am Manikant Mishra, Modern English School, New Area. So, continuously we are discussing about the characteristics of periods. Now today we are going to discuss the characteristics of group in a periodic classification of an element. So the first one, we will discuss about the valence electron. Valence electron. So I have taken example of group 1 and group 17. Group 17. Here you see that group 1 member lithium, sodium, potassium. Group 17 member fluorine, chlorine, bromine. Now as I said, what is the gradation? What is the change in valence electron while moving from top to bottom across the group? You see, in a group 1, the first element is, in a group 1, we are talking about the lithium, sodium, potassium. Here the valence electron is 1. Sodium has valence electron 1. Potassium has valence electron 1. If you talk about the group 17 element, valence electron 7, 7, 7. Fluorine has 7 valence electron. Chlorine has 7 valence electron. And bromine has 7 valence electron. So what does it mean? While moving from top to bottom across the group, valence electron remains same. Valence electron remains same. So the feature characteristics of group regarding the valence electron while moving from top to bottom, while moving from top to bottom across the group, valence electron remains same. Valence electron remain same. So either you talk about the group 1 or group 17, the valence electron while moving from top to bottom across the group, it remains same. Now talked about the valency. Second valency. Now here you see the valency of lithium is 1, valency of sodium is 1, valency of potassium is 1. Valency of fluorine is 8 minus 7, 1. Valency of chlorine is 8 minus 7, 1. Valency of bromine 8 minus 7, 1. So what do you observe? While moving from top to bottom across the group, the valency also remains same. Valency remains same. While moving from top to bottom across the group, valency remains same. Valency remains same. While moving from top to bottom across the group, valency remains same. Now next, size. Atomic size. Atomic size. Here you see the number of cell is 2. KL. Now sodium KLM. Potassium KLMN. Similarly here also you see that in the chlorine KL, KLM, KLMN. So while moving from top to bottom across the group, number of cell is increases. Number of cell is increases, due to which the size of an atom also increases while moving from top to bottom. While moving from top to bottom across the group, the size of an atom increases due to increase in the number of cells. While moving from top to bottom across the group, the number of cells increases, due to which the size of an atom increases. Now next, ionization enthalpy. Ionization enthalpy. Fourth, ionization enthalpy. Once again, ionization enthalpy is what? The amount of energy required to remove an electron from an isolated gaseous atom. Amount of energy required to remove an electron from an isolated gaseous atom. So this thing we cannot talk about the group 17, because group 17 do not have tendency to lose electron, rather it has a tendency to gain electron. So when we talk about the ionization enthalpy, we will talk about only the metal, that what we have taken the example, suppose here group 1, so we are talking about the group 1 only, not for the group 17. So ionization enthalpy, as I said, the amount of energy required to remove an electron from an isolated gaseous atom. So it means, as you know, that the metal has a tendency to lose electron because valence electron is loosely held by the nucleus, and it depends on the size of an atom. The value of ionization enthalpy is prominently one of the factors on which ionization enthalpy depends is on the size of an atom. So while moving from top to bottom, what is happening? The size of atom increases. If the size of atom increases, it means what? F is inversely proportional to the square of the distance between them. It means if the distance increases, the force, electrostatic force acting between the nucleus and the outermost cell electron will be less. Then it will be easier to remove those electrons. So it means as the size of an atom increases, ionization enthalpy value will decrease. Ionization enthalpy value will decrease due to increase in the size of an atom. So while moving from left to right, while moving from top to bottom, while moving from top to bottom across the group, the value of ionization enthalpy or ionization energy decreases. The value of ionization energy decreases due to increase in the size of an atom. Due to increase in the size of an atom. Now let us talk about the group 17. Now as you know that the group 17, what I have taken, or non-metal has a tendency to gain electron. When the extra electron is added to the outermost cell, nucleus welcomes those incoming electron. When extra electron is added to the outermost cell, then nucleus welcomes those incoming electron. As a result, energy is emitted. As your some close friends, close relative comes, then you feel very much happiness. Now that happiness, here we measure in the language of chemistry, that degree of happiness we measure in a chemistry in terms of electron gain enthalpy. Electron gain enthalpy. What is electron gain enthalpy? The amount of energy liberated by the nucleus when an incoming electron is added to the outermost cell. When nucleus liberates energy when extra electron is added to the outermost cell. The energy liberated is called electron gain enthalpy. But when you become happiness, when your close friends, when your close relative comes, if it is a far relation is very far. Suppose I reach you at your home, you may not welcome to me. You may not welcome to me, but when suppose your father is at Delhi, Britain, Washington DC, if he comes, then you welcome. You become very, very, very happy. So that happiness in terms of chemistry, we say electron gain enthalpy. Similarly, so what I am trying to make you understand, closeness from your to that person relation. If it is a very close, then only you welcome. If it is a far away relation, then you don't want to welcome. You don't have interest. So if you don't have interest to welcome, it means the no happiness, very, very less happiness may be that. So the electron gain enthalpy value will be very less. So what does it? It depends on the distance of relation from that person from the person who receives and the person who has come. So my dear students, as I said, the non-metal has a tendency to gain electron. Non-metal has a tendency to gain electron. Now the amount of energy liberated by the nucleus when an incoming electron is added to the valence shell is called electron gain enthalpy. The amount of energy liberated by the nucleus when an incoming electron, when an extra electron is added to the outermost cell, the energy liberated by the nucleus is called electron gain enthalpy. So now we will talk about the group 17, because group 17 has a tendency to gain electron. So for non-metal, the ionization enthalpy. Now, as you move from top to bottom across the group, what is happening? The size of an atom increases. Size of an atom increases. So it means when you add the extra electron, the degree of happiness will go lower and lower due to increase in the size of an atom. So while moving from top to bottom, across the group, the magnitude or the value of electron gain enthalpy decreases due to increase in the size of an atom. While moving from top to bottom across the group, the value of electron gain enthalpy decreases due to increase in the size of an atom. Now next, chemical reactivity. So while moving, next, chemical reactivity. Now you see, when we talk about the chemical reactivity, it means ionization enthalpy for the case of metal and electron gain enthalpy for the case of non-metal. So now, just now we have discussed the value of ionization enthalpy increases due to increase in the size of an atom. So in the chemical reactivity in the case of metal, while moving from top to bottom across the group, the reactivity increases due to increase in the size of an atom. In the case of metal, the reactivity increases while moving from top to bottom across the group due to increase in the size of an atom. Now, in the case of non-metal, the reactivity decreases. In the case of non-metal, the size of chemical reactivity decreases due to increase in the size of an atom. In the case of non-metal, the chemical reactivity of non-metal decreases while moving from top to bottom across the group due to increase in the size of an atom. So these are the characteristics of group. Rest, if anything is left, then hopefully next week we are going to meet in a classroom. So maybe this is the last video. Maybe I am not dead sure, but as per the government rule has already come that from Monday there will be a class and we will meet in the classroom, and rest of the things we will discuss. Till then, bye. Thank you. See you on Monday. Sorry, my students, that while talking about the gradation of ionization enthalpy along the group, the value of ionization enthalpy decreases due to increase in the size of an atom. By mistake, I have mentioned increases the word. So please rectify it. While moving from top to bottom across the group, the value of ionization enthalpy decreases due to increase in the size of an atom. Thank you.